Let's interpret a diagram. So pause the video for like as many seconds as you need and solve for the variable x. This is a variable if you don't know what a variable is. And if you don't, then it's time to retake pre-algebra, guys. So pause the video. I think I did not say that. Whatever. Okay, I expect you pause the video. So how would we solve this? Now, first things first, we cannot use vertical angles because we would say 3x equals 3x. And you know from the reflexive property, any number is equal to itself. So first of all, that's not helpful because you get 0 equals 0. And that's not a solution. But then if you look at the relationship up here, you know these form a linear pair. And you can assume what if something is a linear pair in geometry. Linear pair implies supplements, which implies sum of 180. This is our definition of subangles. So this means 3x plus 12 equals 180. 3x equals 180 minus 12. 3x equals, I'm going to grab my calculator. This is 168, by the way. I probably made mistakes. So I like to second guess myself. And x equals 168 over 3, which is 56. If you want to plug this in, you'll plug it in here. 56 times 3. Sorry. What is 56 times 3, I may ask? Oops. 168. 168 and 12, 180. So, you may be confused like, oh, are we finally getting to do angle proofs? Because we're doing vertical angles. And no, you're never going to. I'll think about it. I'll probably release like 4 videos just cause. 4. Okay, like 3. But notice how we use our knowledge of different types of angle types, specifically linear pairs, to solve for x. This is what this chapter is leading to. So right now we have one line, but what if there was another line that intersected? And what if our number was here? How would we go about solving this? We can't. And there is one key thing in this which tells us we can't. A is not parallel to B. Because A is not parallel to B, you will see that we have next video on this, we'll learn about the different types of theorems, talking about angle types that will be discussed in this video. And the conditional of one of them, about all of them, are if two lines intersected by a transversal, I'll just write out my shorthand that my math teacher made. If parallel lines imply parallel lines. If parallel lines, well, specifically just parallel lines. And when we're talking about parallel lines, we're talking about A and B. What it is saying is, if A is parallel to B, then we will be able to use all these theorems. But you cannot assume parallel lines. Because what if the slopes are very close? I can't think right now. But what if the slopes are honestly like so close, like 151 over 2, 151.1 over 2? That is really not seeable. This is also why you can't assume, like, if a line is 90 degrees, for example. It can look as 90 degrees, it can look at as 90 degrees as possible, but you cannot assume it because it could be an 89.7654321 degree angle. So these are why our parallel line symbols are important. But we're not even talking about how to solve this. That's for next video. There are many different types of angles. Let me see if I can find this. Look at all of this. So it might is one of these. Yes, here. I am not going back. Okay, first of all, how do I close all this? Why can't I close all this? We're not going all the way back just to see. Oh. But I have all of this here. Let's not talk about this one. This is in the next video. But, right? Wow. I have like a whole diagram I made right here. There. So let me just erase this all. I mean, if you want to look at it now, I really do not care. But let's start discussing this. So first, let's talk about the basis of all of this. The difference between the difference between exterior and interior angles, right here. That was just luck. So what are interior and exterior angles? So in a diagram like I showed you, our little angle tangle, the interior angles are formed in between the two lines. Oh wait, first of all, let's talk about transversals. Right here. A transversal is a line that intersects at least any two other lines at distinct points. Wait, I really don't care. A transversal is a line that intersects any two lines at distinct points. I'm kind of dying here. Okay, but anyways, so this line A is a transversal. And why is it a transversal? It's intersecting these 2 points. Intersecting these 2 lines. So this is what a transversal is. So yeah, when I said it's 2 parallel lines, if lines are parallel, our if statement of our theorems that we will see going on. By the way, we will also learn about converses, and that will be a little different. But they will be if 2 lines intersected by a transversal are perpendicular. If 2 lines intersected by a transversal are parallel, then the corresponding angles are congruent. The alternate interior angles are congruent. Yeah. Okay, I don't know why I paused. But the interior angles are formed in between these 2 lines. In between the lines where the transversal intersect. So 4, 3, 5, 6. That's a 6. Or maybe here. For the names of the angles doesn't depend on if the lines are parallel or not, but if they're congruent or not does. These are interior because look, they're formed in between the intersection points of them, in between the 2 parallel, non-parallel lines, just in between the lines that the transversal intersects. And the exterior angles are, well, on the outside, 1, 2, 7, 8. So I'm not going to go in much depth about that, but I got this diagram up here if you want to look at it. In between the lines, outside the lines. Interior, exterior. So first, these are the type of angle types. You may or may not have seen them. So. Let's talk about the first angle type we'll learn. Alternate exterior angles. And so first of all, let's say, I did not know you could do that. That's actually cool. Let's talk about the exterior angles. These are the angles that are exterior on the outside. 1, 8, 7, 2. Alternate exterior are the angles alternate. So 1, 8, 2, and 7. See how they're alternate to each other? 1, 2, 3, 4. 2 and 3 are alternate to 1. So are 1 and 4. But 1 and 3 are on the same side. And so are 2 and 4. So the alternate exterior angles, these are angle pairs, by the way. So this means there are 2 angles, not 1. Interior angle sets are 1 and angle 8, angle 2, and angle 7. Alternate interior angles are angles and the inside are alternate. 3 and 6. 4 and 5. I don't know what this symbol is I'm writing. But consecutive exterior, also known as same side exterior, well, they're on the same side. Angle 1 and angle 7. Angle 2, 8. Consecutive interior. Wow. And corresponding. Corresponding is the most complex, so it's not as basic. But I had something I drew, and this really helps. Corresponding angles, they jump over one of the angles to the next. So angle 1 jumps over angle 3 to angle 5. By the way, they're on the same side. So angle 1 and angle 5 are corresponding. Angle 3 and angle 7. They jump over, 3 jumps over 5 to get to angle 7. 2 jumps over 6 to get to angle. 2 jumps over 4 to get to angle 6. See how they all jump over at least one angle? And 4 jumps over 8. And 4 jumps over 6 to get to angle 8. Notice how we don't go up or down after we get to this angle because, well, there's no more at the bottom. If there were more transversals and more parallel, perpendicular, more lines, then yes, there are more. So these are the angle pairs we created. Alternate exterior, alternate interior, consecutive exterior, consecutive interior, corresponding. And that's it. So I will have like a little thing at the end of this, but okay, and you can hear my wonderful dog barking. So I might make like some cool diagrams and stuff to practice, but that will be it for now. So see ya.